Okay, so present value of single cash flow. Now, what do you mean by present value of a single cash flow? First, we need to understand. So, let's move into that portion. Present value of a single cash flow. When a cash flow is standing in at a future point of time, just what we discussed, that when we are pulling cash flow backwards, it is called discounting. When we are throwing cash flow or money forward, it is called compounding. Compounding increases the amount and value of money. So when you are compounding, when you are investing your money, what will you expect? That if you have invested $100, then will it be more than $100 in future or less than $100? Obviously more than $100. That means that amount of money is growing. That's why it is called compounding. And when it is discounting, what do you mean by discounting? Discounting means that something was standing at future point of time and you are pulling it today. So suppose you were about to receive some money in future, 1 year, 2 year, 3 year afterwards, and you want to know that if I would have received the money today, then what would have been the amount of money, equivalent amount of money. Obviously if you apply the logic of compounding, then also going by that logic, it should not be same, so it should be lower. Okay, present value of a single cash flow. See, first analyze the term. What do you mean by the terminology? Okay, the terminology says, and there are two things. Let me select the pen. Okay, so there are two things in this terminology. First is concept of present value, that we say as PV more commonly, and second thing that needs to be noted is of a single cash flow. Okay, so present value of a single cash flow means only one cash flow which is standing at future point of time. We are trying to determine present value of that. So say for example a cash flow is standing after 3 years of $120, and you want to know what is the exact amount or exact value of that dollar cash flow today. Suppose taking it other way, suppose you are about to receive a cash flow after 3 years, and you are in urgent need of money. You approach someone else and you want to sell that cash flow. First, is cash flow an asset or not? Answer is yes, it is an asset. What do you mean by asset and how do you define asset? See, it's very simple. Anything which is going to give you future economic benefit, anything which is going to give you future economic benefit is an asset. Anything which is going to give you future economic losses is a liability. So anything in future which will give a benefit to you is an asset. Anything in future which will hurt you is a liability. It's very simple definition. So if you are going to receive cash flow or money after 3 years, then will it be an asset or a liability? An asset. And if it is an asset, can you sell an asset or not? Obviously if it's your asset, then you should be able to sell it. So you are trying to sell that single asset, that single cash flow, perhaps an FD, perhaps a bond maturity, perhaps any other form of cash flow, but you want to sell that cash flow. Then the question comes up is that will you be able to sell it? Answer is yes. And if you want to sell it, then what should be the value, or how should you be able to determine the value? Okay, here comes the present value of a single cash flow. It says the concept is very simple. It says that what you are trying to do is that you draw a timeline. You are standing at 0th day and the cash flow is standing at 3rd year, and you suppose the cash flow is $5,000. You want to sell this cash flow and determine at today's date. So you would want to determine what is the present value of the cash flow. Means if I would have received instead of 5,000 an equivalent amount today, then what would have been that equivalent amount which would have made me indifferent towards both the cash flows? Means 5,000 receiving after 3 years and X amount receiving today will make you equivalent and indifferent towards both. How will it make it equivalent, indifferent, and what is the concept? We will discuss it with an example, but I hope you are getting the concept of present value. Present value means today's value of something. Of what? Of something which is standing at future, because if something is standing today, then its value is same now. If money is $100 is in your pocket today, then the value of $100 today is 100 only. But if $100 is receivable after 1 year, then the present value of $100 means the value that should have been today would be different. That's what common sense says, right? So that's why present value of single cash flow, how we determine it, how does it work, we will understand with an example. Okay, so proceeding ahead with an example, I would request you to read example 1 with me. Okay, so example 1, Given a discount rate of 12% compounded annually, what will be the present value of $5,000 standing at 5 years to maturity? Okay, so let me draw a timeline. I think it helps a lot when we work with a timeline. So this is our timeline. We are standing at 0th day and the amount is standing at 5th year. The amount receivable is $5,000 and we are trying to determine present value with an interest rate of 12%. So interest rate is 12% and we are trying to determine the present value of the amount. Okay, so how are you going to determine that? The question is that how are we going to determine that thing? Okay, there are two approaches to it. See, number one is formula method, and when I will write the formula, you will perhaps feel that this formula is something you would have learned in very elementary level of your school and in commercial mathematics. Okay, and the second one would be that we will solve the same thing in Excel. Why are we solving it manually? Because I believe that once everything should be done manually. The reason is that if I throw only Excel towards you and if we only solve in Excel, it would be very easy to solve. However, you won't be able to grab the core concept that how things are working. Number feeding is very easy in Excel, but ultimately the purpose is not only number feeding but to grab the knowledge of how the things are working. So that's why when we will discuss it manually and do it manually, then you will be able to understand that which element and how does the formula work. And then when you go in real life and things and practical situation comes up, then you will have the controlling aspect. Obviously you will be using Excel in real life, but at least you will know how the background and everything in background and the formula in Excel is working. Okay, so that's why we will be solving it manually and I'm writing the formula. I think you should be able to relate to it because it is very elementary formula and you should have come across this formula. Okay, so the formula is FV means future value is equals to present value into 1 plus I to the power n. I hope you should be able to relate to it. FV means future value, means something which is standing at future point of time. PV means present value, means something which is standing at today. I means the rate of interest that is applicable, and N means that time period, time frame for which the investment was made. So if, let's talk verbally, if $100 was invested today for 1 year at 10%, what is the maturity value? I don't think you need this formula. It's very straightforward. It's 110. $100 was invested today for 1 year at 10%. The answer is very straightforward. It is 110. How did you do that? It's very simple. 100 was my original amount. On that I applied 10%. So I got an interest of 10% and the total amount is 110. However, suppose if this is compounded, if I am investing for 2 years and it is compounded annually, then after next year at the end of first year on 110 you will get 10%. So that means the amount will be 11 and that's why you get 121 and not 120, because you are getting interest on interest. And that's what the beauty of compounding is, that compounding is that you compound, you get interest over interest. So say for example, in year 1 you invested 100, in year 0th day you invested 100, in year 1 you got an interest of 10. So the total ending investment at year 1 becomes 110, not 100. And when you are getting interest again in year 2, then that is on 110. That's why it is 11 and that's why you got 121 and not 120, which is what the extra one is the beauty of compounding, and that's why everyone runs after compounding and not simple interest. Well, this was very elementary logic, but yes, this is very straightforward calculation. Apply the same logic over here, and applying the same thing. 5,000, we are trying to determine what, present value or future value? Present value. So I would like to tweak this formula in my favor, and that is PV is equals to FV, which is amount is standing at future point of time, divide by 1 plus I to the power n. Okay, so PV is equals to FV 1 plus I to the power n. Now if I apply this formula again with numbers, that means that 5,000 which is standing at future point of time divided by 1.12. See, 1 plus I here indicates it is in decimal, so 1.12 to the power 5. So if I am to do that, I need a calculator and a scientific calculator. So once I am coming out of screen, Just a second. Okay, and I would need a calculator now. Yeah, I have a scientific one. The reason I'm using scientific is y x to the power y button, because I am to do power 5. So if it would have been a square or a cube or a 4, then it would have been easier. But for doing power 5, 6, 7 or odd numbers, I need this x to the power y function. So even if you are solving it with me, if and you are using your laptop or mobile phone, then please open the scientific calculator and check for the x to the power y button, because that will be required to calculate 1.12 to the power 5. Okay, so what I'm first trying to calculate is 1.12 x to the power 5, and the value of that is 1 point. I'm sorry, I think I applied it twice. One second, let me come out of it. Okay, 1.12 to the power 5, and the number is 1.1762. 1.1762. Now I have to divide 5,000 by this amount. So first, what does this amount mean? Let me explain. This amount means that if $1 is invested today, $1 is invested today, forget about 5,000, $1 is invested today at the rate of 12% for 5 years, then it will become after 5 years 1.7623. Means $100 invested today will become roughly $176. Means $1,000 invested today will become $1,760.62 point something. Means $5,000 invested today should have become something 8,000 or something. Apply reverse mathematics, that 176 standing after 5 years is dollar equivalent to $1 today. We are telling now that there is some amount that will make things indifferent. So if interest rate is 12% for 5 years, then $1.762 is equivalent to $1 today. Means if you are given two proposal, that is to receive $1.762 after 5 years and to receive $1 today, then you will be indifferent towards both if interest rate is 12%. Okay, similarly we are trying to calculate applying unitary method, that if 1.762 becomes 1, then how much 5,000 should become. Okay, and applying the same logic, we can, I hope we can get the answer. So 5,000 divide 1.762. I think it was 762. Yes, 2837.68. So our answer is 2837.68. I hope you got the maths. Okay, it's equals to 2867.68. Okay, so that's what it is. What does it mean? Again, I'm trying to give you an interpretation of how to interpret this amount. I'm sorry, how to interpret this amount. This amount means that if you are given two proposal number one to receive $5,000 after 5 years, proposal number 2 to receive $2867.68 today, you will be indifferent towards both proposal, because given prevailing interest rate is 12%. Because even if you would receive $2867.68 today, you could have invested that dollar amount at 12% for 5 years, and after 5 years that amount will become $5,000. Now going back to our original example, you were in need of money, and suppose you are expected to receive $5,000 after 5 years today, and you are going into the market to sell that cash flow. That cash flow is an asset, and obviously you will be able to sell it at what is the minimum amount that you will charge for that asset, that is $2867.68. So if somebody is offering you lower than $2867.68, that means $2860 perhaps, then will you accept that deal or not? You will not accept that deal, because that is lower than the minimum amount that at which you will sell that cash flow is this. On the contrary, if from the buyer point of view, the maximum amount that the buyer will be willing to pay for this cash flow is $2867.68. That is $5,000 is $2867.68. Because if you charge higher from him, then he will not give you, because he will invest that cash that he was going to give you at 12%, and he will be able to earn more. Okay, so this is the rate at which the deal is going to be striked, and at which the transaction is going to happen, $2867.68. Okay, means the present value of 5,000 if discounted at 12% is $2867.68. I hope you got the maths involved behind that thing, you got the logic, because this is the first time we are doing it, and perhaps for a single cash flow this is the last time we are solving it manually, because now we will solve it with using Excel. Okay, so before going to Excel, I hope the maths is clear. It's very simple. $1 invested today becomes more than $1 after 5 years. 1.762 that we have come across. That means that if something is standing after 5 years, the amount today will be lower. That's the simple logic. It's very simple. If you are doing present value, the amount will be lower. If you are doing future value, the amount will be higher. Because in future you are investing, you are earning interest. When you are doing present value, you have not earned interest, you are investing a smaller amount. So that's what the logic is. If you are doing a PV, the amount will be lower. If you are doing an FV, the amount will be higher. Take it that way. Okay, so simple, 1.762 becomes 1. So how much? 5,000 will become. We have just applied unitary method, and this formula is very elementary. Okay, now how to solve the same thing in Excel? That's the question. So let's move into the discount factor template. Before we proceed, I would like to take a minute to give an information. Number one, as we proceed ahead in our course, for those who are watching it online, or those who have purchased the course and got the lecture and the study material delivered to yourself, be it module 1, module 2, or module 3, or be it any course, this color coding is very simple. We have a clear cut color coding. This color when you have received your study material, the students, then you will see that this area is blank. Area with this color is blank. It is because of you to write it along with me, so that it's not just kind of you just sit back and watch the lecture, because you need to be attentive. Hold a pen when you are watching the videos, so that you are investing your 100% attention to get the maximum benefit out of the course. Okay, so this areas are something where I will write with in my video lectures, and you will be writing it in the notebook that has been material that has been provided to you. Secondly, for online students, and also for students who have purchased this course, all the Excel models for students are already shared with them. Okay, and for online students, these Excel models are available on our website, as well as on the below YouTube link that is in the description in the YouTube video that has been in which it is provided. Okay, so you can go to the description and download the Excel models, and also you can go to our website and download the Excel model. These models are free, for which the lectures has been uploaded on YouTube. Secondly, I would suggest and advise also that if you are watching this video and want to maximize your benefit, then please go ahead and download and solve the Excel simultaneously with me. Otherwise you will be able to forget, you will forget, and you will not be able to solve it. So go ahead, solve the Excel along with me, so that you get the maximum benefit out of it. Okay, I think my information is done. I'm supplied whatever the necessary information was. So let's move out and let's solve the same example in Excel, that how we would have solved in Excel. So first I would like to introduce the interface and make it familiar, the Excel interface, how we have designed the Excel models, because there could have been different Excel models. See, how does it work? Okay, so there are two options. I will explain later why with date, without date logic is there. But firstly, and this color coding is also very common. We have a very clear cut color coding. Yellow color is the field for input, and blue color is the field for output. The Excel models are linked with formulas, so we don't expect you to change or alter any of our models or formulas. Please don't do that, otherwise it will make the Excel go haywire. So just you need to work on the fields in yellow, and the fields in blue will take care itself. Okay, because there is a clear cut formula coding that is involved. Okay, we'll explain the formula as well, how it has been input wherever it is possible. Okay, see, discount rate. this is the rate that we have talked about in our example. What it was, if you able to recall, it was 12%. So let me plug in the number 12. That was what it is. Now when you see the second thing, that is period, it indicates the years. So 0th day means today itself. First year means the year after 1 year, 2 year, 3 year, 5 year, then 10 year. We have kept it in 10 year. You can drag it and keep it till 100 years also. Excel has a lot of space for that. Now, discount factor. What do you mean by discount factor? It's very simple. If $1 is invested today at 12%, how much will it be? Will it be today? If $1 is standing today, then what will be the value of $1 today? You will say, sir, what are you asking? It will be one only, na? That's what it is. That on 0th day, if $1 is invested or $1 is discounted and standing at 0th day, what will be the value of $1? That will be one only. Even if you apply 100% discount rate, then also it will be $1 only, na? Second, if $1 is standing after 1 year, then what will be the value of $1 today? So 0.893. 0.893 will be the value of $1 after 1 year. So if $1 is standing after 1 year, $1 standing after 1 year becomes 0.893 today if the rate of discount is 12%. Similarly, $1 standing after 2 years becomes 0.797. That means you try to apply unitary method and think it. If 1 becomes 0.797, how much X amount or whatever you want to determine will become? $1 standing at third year, end of third year, becomes how much at 0th day? Sir, 0.712. Similarly, $1 standing after 5 years becomes 0.567 today. So it becomes relatively straightforward that we just need to plug in the undiscounted cash flow. Now what is that undiscounted cash flow? The cash flow that is standing at future point of time. And when you apply this undiscounted cash flow, we have 5,000, I think, in our example. You get the output that is discounted cash flow, that is 2837.1. What does 2837.1 means? If $1 becomes 0.567 today, then 5,000 will become how much? That is 2837.1 today. Okay, this was a pure unitary method, straightforward. Now you would be wondering that where we have applied the formula. Sir, the formula is here. Okay, you can see the formula bar. 1 by 1 into 1 plus $D $4. Now what is $D $4? This is our discount rate, that is the interest rate, and y to the power 6, that is the rate, that is the year. So isn't it, if you are able to understand, isn't it the same formula? We have applied it on $1, we have not applied it on 1,000. Why I have not applied it on 5,000? Because I don't know. You can solve multiple examples with this now. That's why I have applied it on $1. And now you plug in $10,000, 20,000, n number of thousands or hundreds or millions, and it will give you your answer. That's why I have to do it in unitary method format and keep it simple. I have applied the formula assuming the $1. Okay, so it's very simple. We have calculated the discount rate, and now use that discount rate to calculate n number of things, n number of present values. It doesn't matter. But the formula is same. Please understand, the formula is same. When we calculated PV over there, then the formula was FV divided by 1 plus I to the power n. Correct? See, that same thing is working. 1 by FV by 1 by. So FV is 1 standing after 5 years. That's what I was telling now. 1 standing after 5 years, how much it will become? So 1 by 1 into 1 plus D to $D $4, 1 plus I. So it was FV by 1 plus I to the power n, 1 plus I to the power D6. Why D6? Because we are checking for D6. Now if it should be after 5 years, then it should be 5. And see how the formula in Excel has changed, and it is I6. I6 means I, that is 5. And that's what it is. If you apply for 10, then you will see N6, because the formula has been made and the Excel functionality is made so that it is fungible. An extra information for the benefit of students who are very new to Excel as well. Why $D $4 has been applied and why it has been free with from any dollar. The reason is that when you apply a dollar sign in Excel after any column or row, then it kind of fixes that Excel. So when you drag that formula, when you plug in the formula and you kind of drag it in Excel, then if you have applied dollar sign, then that row or that column will not change. So See, understand, when I would have applied the formula over here and I would have kind of dragged it, I would have wanted that the year to I would have wanted the year to change as and when I drag it. Will I be want to keep year constant? No, because year will keep on changing. However, will interest rate also keep on changing? No, it will be constant, because 12% is applied for throughout 5 years, throughout 10 years. So that same discount rate is getting applied. That's why I want to fix only this cell but not this cell, and that's why dollar sign dollar d dollar 4 is sign is after 12. That means this cell, but there is no dollar sign or any sign after this cell, and that's what the reason is. Okay, so coming back to the logic, now we have solved it using the Excel formula. This is your timeline basically, if you would be able to recollect, and this is how it works. Now coming to the NPV Excel function, there is an NPV Excel function also, means that Excel also offers you a formula function where you don't have to prepare this table. I have prepared this table to keep things simple, and also it has additional functionality. As we'll proceed ahead, we'll know. But Excel offers one NPV function as well. Now, how does this NPV function work? In any formula, when you type in formula equals to that formula and bracket open, then it will show you what to plug in where. First, it is asking is the rate. What is the rate of discount we should apply for this, and it is D4 in my case. D4 is, I think, the same number what we have selected, so it is the interest rate. When I move ahead, then it is asking me for value 1, value 2 to value n. So I have plugged in value E10, means basically what is there in E1 to D10, I mean N10, and at last I have added $D10. Now why I have done that, I will be in a better position to explain when we'll move ahead to dealing with multiple cash flows. Now we are dealing with only single cash flow, but soon we will proceed ahead and deal with multiple cash flows, and when we'll do multiple cash flows PV at the same time, then I think I will be in a better position to explain. But as of now, take it as a formula of Excel. Basically it is giving you same output, so it acts as a check function for now. Okay, moving ahead to with dates. Now why with date and without date is so much important, and why I have tried to introduce this concept. Friends, I could have stopped and I couldn't have introduced you without date, because it was not much required in stock valuation course. But always my purpose is, and my target is to give maximum information to the students, and to give the maximum information to the students, I think this is something which becomes very important to give you. Now the thing is that when you, if you would have tried to understand, and if you try to understand that, let's take an example. You go to bank, I think you would have visited a bank. If you would have seen the interest rate counter or investment counter, then you will see for 1 year interest rate is let's assume 6%. For if we go backwards, I mean if we shorten the time frame, for 6 months interest rate is 5.5%. For 3 months interest rate is 5%. For 1 month interest rate is let's assume 4%. For 15 days interest rate is, say for example, 3.75%, and for 1 day interest rate is, let's assume, 3%. Now what the hell is that? That means that you have an option not to invest only annually. You have an option not to invest only annually. When we think and talk in terms of investment, it becomes very easier to grab when things move annually. But in real life, does only annual things work, or there may be a different frequency than annual? Obviously, there may be different frequency than annual. The reason is that, and that in real life things don't work annually. If you apply common sense, you have money only for 3 months, then what will you do? You will wait when you will have money for 1 year, or you and you will not earn interest, and you will keep it in your at your home, or you would like to earn interest for 3 months? So answer is very straightforward. Yes, you will like to earn interest for 3 months. Even for 1 day you have that spare money, then also you will be like to earn it. Friends, you would, I don't know whether you have learnt about money market or not, but in capital market there is a very big ambit called money market. In money market, we are talking about daily interest, but in money market people get paid hourly interest. Yes, you are getting it correct. They are paid hourly. Now, how money market work? Firstly, it's not for us like retail investors. It's for big corporates and HNI investors. So, assume an Apple, a Samsung, which has a $250 billion of cash, or even a Reliance Industries, which has a millions and millions dollars of cash. They have a separate treasury division. They have a separate division of treasury which hires lot of CFAs, a lot of chartered accountants, and those the purpose or one of the purpose of those that division, treasury division, was to manage the inflows and outflows of the corporate. And it so happens, and the function is to earn interest out of them, out of that gap. So suppose a Reliance Industries is there, and Reliance Industries has received a payment of dollar 500 crores, or five, say for example INR 500 crores, and it is received at 2 p.m. and it is about to pay it to someone else at 5 p.m. and that money is lying idle for 3 hours. My question is that if you are given an option number 1, just to sit back and relax and don't pay any heed to the interest that you could have earned for 3 hours. Option number 2, you can earn an interest for 3 hours. Would you like to earn it? What would be your answer? Answer is very straight. Yes, I would like to earn an interest for 3 hours. And that's how the corporate and treasury divisions manages it. Even when bank to bank working is done, then suppose a bank has branch of a bank is running short of funds, and there are a lot of depositors who have come to the branch to who have visited the branch to withdraw their money. Then what will they do? What they generally do is that they offer or they order their head office to send cash, but obviously that cash transit may take some time. It may so happen that the other division or the corporate head of corporate understand that which are the other banks who are near the corporate, near that branch, and they may coordinate at branch or head office level to the other bank and order the other branch of the other bank to give supply some cash, maybe for 2-3 hours till the time the cash is in transit, and they are getting paid interest on that 2-3 hours also. So my purpose was that please come out of the shell of annual. There is no such thing in life called annual. Annual is just a part. It can be semi-annually, it can be monthly, and there are every likely equal chances of being an annual, as equal as being an hourly, as equal as being a monthly or a half yearly or a bi-annually. Okay, so annual is very good number to deal with, but now we will have to come out of annual. Now this Excel without dates will not help you when you want to come out of annual, because this Excel has been designed only on the basis of annual. That's why we have designed with dates concept. What does with dates do? You need to plug in the date on which the investment is made, means the cash was out, and the day on which the amount is matured, and means the cash will come in again, and the Excel will calculate the number of days. It's very easy for Excel to do that, and based on the number of days the interest will be calculated. So this time the present value is getting calculated, but based on the number of days and not on the number of annual, not on the basis of 1 year, but on 365 days. Sir, how will it make difference? Friend, it will make difference, and you will soon see it, because there are leap years. Because there are leap years. So when you will have a time frame of 5 years, there will be perhaps at least one or can be two leap year. And if there are two leap years, then the 2 days extra interest is getting deducted or paid. If you are calculating future value, the value will be comparatively higher for 2 days. I hope you are getting my point. That if you are doing it, if you would have solved the same question on the basis of annual, you would have taken 5 years, but this time Excel will not take 5 years. Excel will take 365 into 5 plus 2 days or plus 1 day, depending on the number of leap years that appears, and the one or extra 2 days interest will also get accounted for. So now I think you will be able to understand when we will deal with semi-annual, annual, 9 month, 6 month, 7 month, 8 month, 23 days, whatever number you want to take. You just need to plug in the days, and you can get the present value and future, exact present value and future value for that, for those days. Okay. First, let me try to solve the same sum. Let's solve the same sum. So I hope you have opened discount factor template, and in that discount factor template we are in the sheet with dates, and we are trying to again plug in the discount rate. So first plug in the discount rate, solving the same example. Now I need to plug in the date 08/11/2019. Okay, now the next is 08/11/2020. One second. 08 11 2020. Suppose I want to go annual only. I don't want to now check for the other things. Just select the two cells. See, there is a end cursor that is coming in, a plus sign. Just drag it. When you drag it, then the other columns will also gets filled on an annual basis. Means 2020, so 21, 22, 23, and so on and so forth till 29. Okay. Now coming to the next line, that is number of days. Now this time my Excel is calculating number of days which was missing in previous Excel, because that's what not the purpose with which for which it was prepared. See, first year means 2020 has 366 days. Why 366? Because 2020 is a leap year. Then we have 365 days, but 2024 again is a leap year, that's why it has 366 days. Why I am highlighting this? Because it's very simple that Excel is going to calculate on the basis of days and not on the basis of year. Okay, fraction of a year, it's showing 1, means how much that equivalent amount or fraction of the year is. It's showing 1, but if I would have allowed a decimal place to 10th time or 20th time, then it would have showed 1.00000, perhaps maybe 10 20 zeros and then a 1, and then an extra 1 indicates that it is not a perfect 1 year, it is something more than 1 year. Okay. Similarly, it's calculating cumulative years, 1, 2, 3 years. That's what I have already explained the concept of discount factor. Again, I'm not going to repeat that, but the logic remains same and the formula also remains same. So if you check, you have applied the same formula. What I have done is that I have converted number of days into equivalent years, cumulative years. Okay. Now apply undiscounted cash flow. So let's take the same example of 5,000, but this time you get a different answer. Wow. And the answer is 2835.4. Previously my answer was 2837.1. Now my answer is 2835.4. Sir, how is it different? 2837.1, it was more. 2837.1, now it is less, 2835.4. So isn't it intuitive? I mean, it should have, before solving, shouldn't you have tried to calculate or understand, or at the back of mind you would have got the message that it would be lower and not higher? Why? The reason is, when you are discounting it on an annual basis, you are taking 5. But just now we discussed that there are leap years, and leap year would have a tendency to discount it for extra 2 days. If you are discounting something for extra 2 days, the amount will be lower or higher, the ending amount. You are discounting it, you are not compounding it. Had it been a compounding, the ending amount would have been a higher for dollar from by dollar 2 days, but you are discounting it for extra 2 days. So perhaps in the without date, from 5th year to 0th year, you have bought it till here. Okay, but you now this time you are discounting it for that extra 2 days. If you are discounting it for the extra 2 days, then you will get a very minimal but lower amount, and that's what is getting reflected over here. Okay, I hope the concept is clear. 5000 2835. Again, X and PV functionality. How does it work? It works with rate, value and dates. So there is another functionality of NPV in Excel which is called X and PV, where you need to plug in date, rate, that's same, values, that's also same, which was there, but this time it calculates on the basis of dates. So as you can see, it is also getting the same answer, that is 2835.4. Okay, I hope the thing is clear. Now let's move ahead to the concept of future value. If present value is clear, then it is very obvious that future value concept will be relatively easier to understand. Okay.